Hey guys, welcome to my channel. I'm LeetCoder. If you guys are new here, I pretty much do LeetCode style questions and explain things in the simplest way possible. Today we have a pretty interesting problem that I'm very excited about. So let's go ahead and read the problem statement. All right. So the problem's called a lowest common ancestor of a binary tree, guys. So let's read the problem statement. It says, given a binary tree, right, find the lowest common ancestor of the two given nodes in the tree, right? It says, according to the definition of LCA, right, the lowest common ancestor is defined between two nodes P and Q as the lowest node in T, right, that has both P and Q as descendants, where we allow a node to be a descendant of itself, right? So which is a very, very good thing that it tells us that, guys. So they made it bold for a reason, guys. So it's a very, very important thing that we should remember as we're solving this problem, guys. So yeah, we're given this so we did a problem similar to this one, right? It was called lowest common ancestor of a binary search tree, guys. So that problem was pretty good. It was an easy problem, so it's a pretty much easier version of this problem. So you guys should check that problem out so it can kind of help you out, right? So check it out and come back to this video. So yeah, guys, so we're giving example one, right? So as you guys can see, we're giving this binary tree, and we're giving 5 and 1, right? P and Q, right? And then yeah, it says our job, right, is pretty much to find the lowest common ancestor, right? So the lowest common ancestor of 5 and 1, right? Definitely 5 and 1 is 3, right? Because, guys, right? Yeah, there are 3. 3 is the lowest common ancestor that they have in common, guys. What I'm saying, lowest common ancestor. So that's why 3 is the one, right? And this one, 5 and 4. 5 and 4. Right? The lowest common is 5, guys, because, guys, it says since a node, right, can be a descendant of itself, right, according to the definition. So that's why, you know, you're probably saying, well, how come 5? How can it be the lowest common? But it tells us we're allowed, right? 5, a node can be a descendant of itself. So that's good. So I'm saying, so because they have 5 and 4 in common, and 5 can be the lowest common ancestor, I'm saying. So we have 1. So we have this tree, 1 and 2, right? The lowest common ancestor is going to be 1, right? Pretty much the root, guys. So pretty much the same case as this one, right? As the second example, right? Where a node is allowed to be a descendant of itself, guys. So it says we're guaranteed that the two nodes are going to be in there. So we don't have to even worry about, you know, case where it's not in there. Right? So that's what's really good about this problem, guys. So so how are we going to solve it, guys? No, what's the intuition, right? So you can see this. Let's look at example 1, right? So 5 and 1, right? Pretty much, guys, you know, we could see that the lowest common ancestor is going to be the lowest node, right, that knows both about P and Q, right? Pretty much the same way we solved the other problem, guys. So you see, yeah, exactly, yeah. A node can be the lowest one, right? Can be a descendant of itself, right? So that's good as well. So pretty much, guys, know how we're gonna solve it, guys. It's gonna be very intuitive, right? We're gonna have to traverse the tree, pretty much, right? No, we can't not do that. So we're gonna traverse the tree, right? And then pretty much, guys, we're gonna cover certain cases, right? So pretty much we're gonna cover this case, right? If we encounter a node, right, which is P or Q, right, we're gonna return that node to the caller and say, oh, this node is gonna be the what I'm looking for, right? The lowest common ancestor, right? No, which is clearly this case, right? I'm saying, so we're passing P is 1, right? Q is 2, right? So then the root is P, right? So we return automatically to the caller, right? Which is us, right? That 1 is the lowest common one, right? We're not even gonna bother searching the rest of the tree, guys. No, whichever one we find first, right, we return it to the caller and we stop, right? This case as well, right? 3, we went left, right? We searched for the left side first, and then we see that 5 is P or Q, right, which is P, right? And then we return automatically. We return that to the caller, and we were done, guys. We don't bother searching, what I'm saying, the rest of this this tree right there, I'm saying. So we search it, we find it, and then we just return it, right? I'm saying we return that to the caller, guys. So yeah, so we take care of that case, right? So let's say what's the other case, right? A case where you're not P or Q, right? So now we're gonna recursively search the remaining of the tree, right? I'm saying the remainder of the tree to find P or Q, guys. And then now if both, so like if a node, right, knows both about P and Q, right, at the same time, right, so they branch out, right, you know what I'm saying, the lowest, you know what I'm saying, so that node is gonna be the lowest common ancestor, right? That means that the node's gonna get a signal from its left, right, and also get a signal from its right, right, telling us that P is in my left subtree and Q is in my right subtree, right? So I know about them both, right? So I can safely return, say, yo, I'm the lowest common ancestor, right? So the other case, right, where I'm not so I don't know about both P and Q, right? So I only know about one of them, right? So I just keep recursing, like, keep bringing the answer up to the caller until we tally, right? You know what I'm saying? So yeah, so the case, so let's handle this case, right, where let's say the P and Q was 7 and 4, right? The lowest common ancestor will be 2, right? And then 2 would say, all right, cool, I'm the lowest common ancestor, so I'm gonna return myself, right? Because I know both about P and Q, right? Because I got a signal from both my left side and my right side, right? So now 2 returns to 5, right? Say, yo, I found P and Q on my right. I found P and my Q in my subtree, right? So I'll return to you, right? So 5 sees that there's no it can't find P or Q on the left side, right? So that cool. So I'm just bring the answer back up to the caller, right? You know what I'm saying? I got an answer from my left side, so I'm just gonna return now I got an answer from my right side, right? I'm gonna return answer from my right side. So we just keep returning from the right side, bam, 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 and then until 3 returns the answer that it got, right, from 5, right? Because P and Q is not in the right subtree, right? So 3 just returns to the caller saying, yo, I found, this is what I found in my thing, right? 2 is the lowest common ancestor, right? All right, so hopefully you guys were able to get it, guys. So let's go ahead with the implementation, guys. So hopefully it was kind of intuitive and you guys were able to understand what I'm talking about, right? So how is it gonna go, guys? So it's gonna be very, very intuitive at the implement. So we got return, guys. So we're gonna be using a helper function, guys, to kind of help us do the traversal of the tree, guys. So we're gonna pass in the root, we're gonna pass in P, and we're gonna pass in Q, guys. So now we're gonna go ahead with the implementation, right? So pretty much, guys, we're gonna return a tree node helper, right? Pretty much the same thing as this one, right? You know what I'm saying? We just like using helper functions, make it clean, cool. You know what I'm saying, keep it consistent. So right now, guys, we know what we talked about. So if root equals null, right, then we're simply gonna return null, right? Or could say return root, doesn't matter, right? Say it's null, right? Same thing. So now the case, guys, the first case that I talked about, guys. So if the root, right, equals to P, or the root equals to, right, Q, right, either or, we just return the root, right, automatically, right? So if it's not that case, guys, then we're gonna recursively, guys, check our left and right subtree, right? Subtrees, right, for the thing that we're looking for, guys. So helper. So we're gonna pass in root that left, right? So check our left subtree, right? We're passing P, we're gonna pass in Q, and we're gonna do the same thing right there, guys. P, Q, right? And then we return the root, right? No. We're not done yet, right? So we check both our left and right? So now I'm gonna search the rest of the tree, right? My subtree, right? So now I wait till I get an answer, right? So the answers that I get, right, I'm gonna act accordingly, guys. So if my left, guys, is not null, right, and my right is not null, right, that means I found both P and Q in both sides, right? So I found P on my left side, or I found Q on my right side, right? Or I found Q on my left side, or P on my my right side. So vice versa. It's pretty much, they're not on the same side, right? You know what I'm saying. So if that's the case, guys, I return myself, right? I'm like, cool, I'm the lowest common, all right? Because that's where, yeah, yeah, so kind of handle that case that we talked about, right? So, which is, what I'm saying, this one, right? The first case where, 5, we found 5 on the left side of 3's left side, right? And then we found 1 on the right side of 3, right? So now 3 says, all right, cool, I'm the lowest common one, because, they're not on the same side, and I'm know about both of them, right? Because they came from both sides, right? So I'm the lowest common one. So that's that case, right? Yeah, so I got an answer for both. So now the case, right, it must be one or the other, right? So now that means one of them's null, right? Or they're both null. So if left is equal to null, right? Then I return the right side, right? Otherwise, I return the left side, right? I just keep bringing up the answer that I got from my subtrees, right? So this is the case. That's the case right there, right? Where we 5 and 4, right? 5 returned, you know what I'm saying? We got 3 got an answer from the left side, right? But, right, 3 did not get an answer from the right side, because, there's 4 P and Q's now on the right side, right? So 3 only got a call from the left side. So we check. Are they both not null? That's not true. So now the left, we check the left is going to null, then we return the right? If and then now if it ain't going to this thing, right, then we return the left side. We just bring the answer up to the column. So now 3 is going to return 5 to us, right? Because it got an answer from 5, right? It wasn't null, right? I'm saying, yeah. So pretty much, when we don't find P and Q, right? I'm saying we return null, right? We make it clear for you guys, right? So Rudy's null, right? And return null. So if we don't find P and Q in the subtrees, right, we're gonna get a null signal, right, from our subtrees, guys. So that's how we're able to act accordingly based on the answer that we get from the subcalls, right? So let's check, see our logic was correct, guys. Seems like it's correct. Seems like we are in good shape. So let's press submit, guys. See if we pass all these test cases, guys. Awesome, guys. We're able to pass all the test cases, guys. So hopefully you guys were able to understand my logic and hopefully understood everything that I just talked about. So I want to thank you guys for taking the time to watch the video. If you guys found value, make sure to give me a like. If you guys are new here, subscribe to the channel, because I'll be doing a lot of other videos just like this one. So I want to thank you guys for watching, and I'll see you guys in the next one.